Hello everyone. So today we'll talk about a new chapter, that is theorem on area. Okay. So this is theorem on area. Now what do you mean by the area of an closed figure? Okay. So if I talk about this one, so if this is a triangle, hmm, or you can say this is a square, this is a rectangle, hmm, or you may say this is a circle. All these cases there is a this is a all are the closed figure. All are here the closed figure. So area enclosed by this, that means this portion you need to consider, right? This portion you need to consider. Here also this portion you need to consider. Here also this whole portion you need to consider. Here also this portion, right? So this is how we know the area. That means the region. That means all the cases we are taking the region. So this is the area. Now how we measure? That means the area of a square. That means if I talk about the square, that is the area of a square of side length 1 is called as 1 unit square. This is the area of enclosed figure is measured by the square unit contained in that region. That means in each cases there will be a square. How we measure the area? That means in each cases there will be a square, small square. Here 1 unit, this is 1 unit, this is 1 unit, this was all sides are 1 unit, so the area will be 1 unit square. For this kind of square will enclosed here in like this way. And how many square are enclosed? How many square can represent this whole area? That is called the total area of the following figure. Here also, if I take this type of thing, right? Here this way. This way we all enclosed all the figure like this. And how many squares are there? Complete squares are there. That would be represent area of the following figure. This is how we measure an area of the figure. Now there is some area options. That is if the that is if for the rectangle the product of its length and breadth represent the product of the length of breadth represent the area of the rectangle. For the square, all sides are equal. For the circle, there is a definite formula to finding out the areas. So this is how we can find out the areas. Now the main thing here that is need to know area of congruent figure. Area of congruent figure. What do you mean by this? Area of congruent figure. There is two congruent figure we consider. First of all, this is, and suppose this is the figure. This. Okay. So these two figure we consider as a congruent figure. That means this is congruent to each other. Then if ABC is one and this is I know as PQR. So in these cases that ABC congruent to PQR, right? So we can say the area of ABC, triangle ABC definitely, this is equal to area of triangle PQR. This thing definitely hold. Okay, and this is called the area of congruent figure. Now there is addition option for the area. Addition option for area. Addition option says that if there is a enclosed figure like this, like there is a triangle over there, and we have a square here, a rectangle here, like this. So this is a figure we have. Now I named this, label this figure like this, that is A, B, C, D, E. Okay. So now if we have to find out the area of this figure, this following figure, then what we shall do, that is area of the region, this equal to the area of the rectangle, that is ABCD, plus the area of the triangle ABC. Sorry, not ABC, that is CD, right? Triangle CD. That is the addition of. That means these two area, this area, this area, this portion area, and this portion area will be multiplied. Okay, this portion area will be, sorry, added for the whole portion area. If I have to find out, then what we will do, that is we will add the two portion, that means this yellow portion and the green portion, or the blue portion, whatever the color it is, that is, that should be multiplied. Okay, next. Now we have the theorem on parallelogram. There is some theorem on the parallelogram, that is that we need to know. There is area theorem. Definitely we need to write like this. There is area theorem of parallelogram. Area theorem of parallelogram. In these cases, we need to consider a parallelogram like this. So this is a parallelogram we have, and there should be a diagonal like this. And for this, if I label this A, B, C, D, so these two triangle, that means the area of triangle ABD equal to area of triangle BCD, and this is equal to half of the parallelogram, area of the parallelogram ABCD. This you need to know. That means these two angle, these two triangle will be there. Like this is the triangle, one triangle we have, and this is another triangle we have. This is another triangle we have. So these two triangle area will be same, and the area of this whole parallelogram, this is equal to the sum of these two triangles. That means the half of the area of the any one of triangle. So this is equal to half of the whole parallelogram. Okay. Now one more theorem are there. That is one more theorem are there. This theorem says that parallelogram on the same base and between uh, the same parallel line are equal in area. Okay. So how we can say this one? That is, if I draw the figure, that is one figure will be look like this. there will be two figure there in a two parallel lines are there. Okay, from here there will be, and from here there will be like this. Not like this actually. Like this. Hmm. So here you can see that this is somehow extended, and if I put the name here, that is this is A, B, C, D, and this one E, this one F, and this is I named as H. So here you can see that the parallelogram are in the same base. That means AB is the ABCD parallelogram. You can see here that two parallelogram are there. One is ABCD, another is ABEF, are two parallelogram, right? On the same base, on the same base, AB is the same base for those two triangle, and the same parallel line, and what is that? That is AB, D, these two same parallel lines, and there is two parallelogram actually. So their area will be definitely equal. The theorem says that their area will be definitely equal. So the theorem tells us that is the area of parallelogram ABCD is equal to the area of parallelogram ABEF. These two, then if this condition holds, then these things will definitely hold. Okay. Okay. There will be next. There will be some more theorem in this session. There will be a separate video for that. Okay. So stay tuned for this.